All right, so today we're going to talk about factoring. We're going to start talking about factoring, the very first step, which is GCF. So what's factoring? Well, factoring, remember on the last lesson, we talked about going forward, which is multiplying polynomials. And everything that we learn how to go forwards with, we got to go backwards with. So today we're going to start talking about how we go backwards. All right, and the very first step is called GCF, which is the greatest common factor. So let me talk about what factors are. So factors, if you were to find factors. So for example, if I was to break, let's say 24 down, okay, and we were finding factors of 24, basically we're looking for numbers that would go into 24. So like I know that 1 times 24 is equal to 24, hence 1 and 24 are factors of 24. 2 times 12, 2 is a factor of 24, so it's 12. 3 times 8, and 4 times 6. So these are all factors of 24. Okay. Now, I may ask you to find primes. Okay. Oh, well, before I do that, let's talk about factors of prime numbers, right? If it was a prime number, then the factors of it is only one in itself. And you're like, what does that mean? So let's say, for example, 19. If you were to try to find factors on 19, you're only going to find 1 times 19. Nothing else. There's nothing else that multiply together to give you 19. So if it only has a factor of 1 in itself, then the original number 19 is a prime number. Okay? So the other thing is I'm going to ask you to break things down to primes. Okay, and you've heard this before. This is where in school you did factor trees. Okay, so let's say I wanted to break down, I don't know, let's say 28. Okay, if you broke down 28, if you broke down 28, you'd be like, okay, so it's 2 times 14. And since 2 is a prime number, you just bring it down and then break down to 14 is 2 times 7. So once the end result is primes, then we know that 28 is equal to 2 times 2 times 7. You can check this. You can type in your calculator 2 times 7, and the result will be 28. So let's say I break down 32. So you'll say, okay, 2 times 16, 2, 16 breaks down to 2 times 8, bring the 2 down, bring the 2 down, break down 8, 2 times 4, bring the 2 down, bring the 2 down, bring the 2 down, break down 4, 2 times 2. So we know that 32 is equal to 2 times 2 times 2 times 2 times 2. Okay? So there is an easier way, well, I shouldn't say easier way. It's the same amount of work, however, it takes up less space. So let's take a look at what that method is. So let's say I'll use this right here. So let's say 28. So I'll ask you what goes into 28. You'll say, well, 2 does. I'm like, yep, that's correct. And then I said, okay, how many times? You're like 14. I go, okay, what goes into 14? You'll say 2. I'll ask you how many times, you'll say 7. Nope. You'll say 7. So in other words, every time I ask myself what goes into that number, I always want to use prime numbers, okay? And then I want to make sure that I end with a prime number as well. With that being said, what I know is this little L right here, 2 times 2 times 7 would be also my primes of 28. Okay, so it still comes out to be the same, but the blue and red method right there will definitely be less space than a factor tree, okay? So that's one thing. So these are with numbers, but if I was to do it with variables, if I was to do it with variables, that'd be easy. Whoa. Because if I had x to the third, that would just break down to no numbers, just x times x times x, right? So variables are very easy to break down to primes, but numbers are a little bit tougher to do, all right? So let's say I had to find, the problem asked me to find the GCF of 28 and 32. Well, I know that 28 is equal to 2 times 2 times 7, and 32 is 2 times 2 times 2 times 2 times 2, okay? So what I want you guys to look at is this. I want you to look at 28 and 32 as like a basket or 2 bins, okay? And what happened was these bins, let's say they are like little $5 gifts, and you have a set of twins that you want to buy something for, and you want them to have the same gifts, okay? And 28 bin has a 2, a 2, and a 7 to sell you. And the 32 had a 2, a 2, a 2, a 2, and a 2 to sell you, okay? So you want whatever you take out of the first bin, you want to get the same thing out of the second bin. Same thing with the next gift, right? So if you look at this bin has, oops, let's undo that. Let's make this bigger. Actually, let's use a different color even. So if you look at this bin has a 2. This bin has a 2. Awesome. So you're going to buy that set. This bin has a 2, and this bin has another 2. You're going to buy that set. Does that bin have a 7? Nope, no 7. Okay. So you're like, okay, let me check the 32 bin. Does the 28 bin have another 2? No. Okay, so you're like, okay, so that's not going to work. So that is all it's left. So that's what's in common. So therefore, the GCF of 28 and 32 is 2 times 2, which is equal to 4. So that would be my answer. There we go. All right. I hope that makes sense to you. All right. So with variables, it's easier because with variables, so this is finding GCF with numbers, but with variables, it is going to be the one with the smallest power, okay? But don't forget, it has to be the same base, all right? Okay, so another way of finding GCF is this. So 28, if I was to break those down to factors, so this is, let's call this method 1. And let's talk about method 2. Okay, method 2 is that you can say, okay, 28, let me find the factors of 28. 28 is 1 times 28, 2 times 14. Is there anything else? 4 times 7. Okay, and you can do this in your calculator as well. You put in 28, divide by 1. 28 divided by 2, 28 divided by 3, 28 divided by 4, 28 divided by 5, 28 divided by 6. So anything that gives you a number that is a whole number, then you can go ahead and use. Okay, so these are my factors of 28. If I broke down 32, it'd be 1 and 32, 2 and 16, 3, 4 and 8, 5, 6, 7, 8. Well, 8 is already back here. So these are my factors of 32. And if you're looking at it, so it's the greatest common factor. Because obviously, if you look at 1 is common, 2 is common. However, the 4 is the largest, right? The greatest common factor, all right? So that's why, again, the GCF is going to be 4, okay? Oh, that's a really big arrow. All right, so you might be asked to find GCF. So some problems are going to have you find GCF, and some of them are going to ask you to factor. Okay, and obviously you need to know the difference of those two things. So let's talk about the difference of those two things. Okay, so with GCF, so let's say for example, it might ask you this. You know what? I'll put it in this form here. X to the 5th, y to the 4th, z to the 4th, minus y squared, z to the 4th, plus x, y squared, z squared. Okay, so this will help with also just the variables as well. So if you look at this, how about if I put it this way? Let's do it this way. So let's look at all the same bases. So here is x to the 5th. Here's an x. Y to the 4th. Y squared. Y squared. Trying to pick some nice colors here. Z to the 4th, z to the 4th, and z squared. Okay? So those are the things that we want to look at. All right? So again, there's 3 bins here. All right? So the 3 bins is, let me write it out. How do I want to do this? I'll do it this way. This has none, this has 1. Shouldn't do that. I should do this. Y to the 4th. This has y squared, and this has y squared. And then z to the 4th. Z to the 4th. And z squared. Okay? So GCF would be, if you look at it, do I have any x's that I can take out? Well, let's use purple. No, because if I was to take one of the x's out of here, there's no x's here to take out. So therefore, I can't, GCF of x is not there. Y, ooh, I can take another y out. Awesome. I can't take a third y out. Z, awesome. Awesome. But I can't take another z out. Okay? So my GCF would be y squared and z squared. That'd be my GCF. Okay? So with factoring, what I also need is what's left. Okay? I also need what's left. Okay, so if whatever I highlighted is gone, what's in the first bin that's left? Well, if I look at the very first bin here, okay, so I'm looking there to see what's not highlighted. Well, what's not highlighted is x to the fifth, y squared, z squared, right? And then let's keep on looking. So let's look at the y's. I'm sorry. Now let's look at the second bin. What's left? Just a z squared, but minus z squared. And that negative came from there. And then we look at the third bin. What's left? Plus x. So this whole thing here, including the GCF, is called factoring. Okay? So if they ask me to factor, then I want that whole thing. If I only ask for GCF, it's just that piece there. Okay? What is in common in all three bins. But if I'm factoring, then I want everything. I want what's common in the bin and what's left in the bins. Okay? So think of it that way. All right, let me see what kind of examples I have for you. Okay, so let's get into some examples here. So let's say it asked me to factor 24x minus 18. Okay, so I have to break down 24. Wow, I'm writing really small here. Let me just redo this. 24. And 18. Okay, so if I look at that, I have 24 breaks down to 2 times 2 times 2 times 3 times x minus, and 18 is 2 times 3 times 3. So again, I look at what's in common in both bins. This bin has a 2, so does this one. This bin has a 3, so does this one. Is there anything else in common? No. So my GCF, I should bring the green back here. Let me bring the green back. All right. So my GCF is going to be a 6 because it's 2 times 3. And then I'm going to have what's left. In the first bin, I'm going to have a 4x left minus a 3. So there is my answer. Whoa. Not what I want to do. I wanted the box. And there's my answer right there. Okay? So that's factoring. So the green is my GCF. The green and the black gives me the factoring part. Okay? All right, let's try this one here. 8x to the fourth minus 72 x to the third plus 32x squared. Okay, now some of you guys might be good at GCF saying, hey, what's the largest number that goes into 24 and 18? You guys could be very good at that. But the ones that are not good at that, breaking them down, the more you break them down now in the beginning, the better you're going to be later on with it. Okay, and factoring is going to stay for the rest of the semester. Okay, so once you learn it, it's going to keep on going. So don't think after the module, the second exam, that everything's just going to go away. Okay, factoring is going to stay with you for a while. All right, so now we have, again, 3 bins here. All right, so the 8, if I was to break it down, is going to be 2 times 2 times 2, x times x times x times x, minus. The 72 is going to break down to, you know what, let's use a different color. 72 is going to break down to 2 times 2 times 2 times 3 times 3 times x times x times x, plus And the 32 is going to break down to 2 times 2 times 2 times 2 times 2 times x times x. Okay? So, if you don't believe me, go ahead and put those in your calculator and see if it comes out, or do the factor tree and see if you get the same thing. Okay? So let's see what's in common. Looks like all three of them have 3 2s. Okay? And that's it for the numbers, right? If you look at it, 8 does go into all three numbers. All right? If you look at the x's, remember what I said before. With variables, a GCF is the one with the smallest power, but the base have to be the same. Okay? And the base is the same, the one with the smallest power. And look at this, though. This has 2 x's, 2 x's, and 2 x's. So that would be x squared. Awesome. So my GCF is 8x squared. What's left? I have x squared left, right there. I have minus 9x. And then I have a plus 4. So there goes my answer. Right there. Okay? How is that so far? Not too shabby? All right, so the next thing I want to talk about is this. What if... So, if I said to you, I have a 2a plus a 3a, you'll tell me that the common thing in here is going to be an a, leaving you with 2 plus 3. Agreed? Okay, if I said 2 times person plus 3 times person, you'll tell me that the person is in common, and you're left with 2 plus 3. Right? If I said 2 times the parentheses plus 3 times the parentheses, you'll tell me that the parentheses are the same, and I'm left with the 2 plus 3. Okay? And I know that 2 plus, these are, like terms, so I could have just added them, but I wanted the sake of talking about the GCF still. Okay? So, again, that's in common. That's in common, and this is in common, okay? And the reason why I want to bring that up is because the next example is going to say, hey, look, I have a 6x times a z plus 6 plus a z plus 6. Now, on the second z plus 6, what is in front of that? Remember, it's an imaginary 1 that's in front of it, right? So you got to remember that. If there's a parenthesis with no number in front of it, there's always a 1 in front of it. But if I was to look at the whole thing, what looks the same? What's in common? And you're going to say, well, they both have a z plus 6. You're absolutely right. They both do have a z plus 6. So that is my GCF. Not GCH, but GCF. Okay? Well, what's left? If you look at what's left, from what I highlighted, it's going to be this and this, which is 6x plus 1. Okay, so this is my what's left. Okay, so those two things are part of factoring. So there is my answer. Okay. Let's see if I have another one set down for you guys here. Well, I do. So let's take a look at this. 5x times 5x to the 8th plus 7 minus 2 times 5x to the 8th plus 7. Okay, so I got 2 bins. What's in common? These 2 parentheses. Look, this is exactly the same, right? So my GCF is going to be 5x to the 8th plus 7. Well, then what's left? 5x minus 2 is what's left. And that would be my answer. Okay? Not too shabby. And the reason why they're doing this is because it's leading you into something new. All right? We're still talking about factoring. But we're going to talk about step 2. And one of the steps in step 2 is called factor by grouping. And this is mainly for you know what? I want to rewrite this, actually. Step 2, factoring 4 terms. And we use some called factor by grouping. There we go. Okay. So with factor by grouping, there's 4 terms. So anytime you see 4 terms, you think factor by grouping. Okay. So let's do an example here. And I'll write the steps out as we're going. Excuse me. So if I had AB plus 7A plus 2B plus 14. Okay. So step 1 is going to be split you know what? Let's use a better word. I think I used separate. Yep. So let's separate. Wow, I can't write tonight. Separate the first 2 terms with the last 2 terms. Okay, the first 2 terms, we're going to call this the first group. And this is, we're going to call this a second group. Okay, so, ready? This is first step. It's very hard, very difficult. Ready? Are you sure? Here we go. Whoa. That's step 1. I know, I'm funny. All right, step 2. Step 2 is to factor each group separately. Okay, so I'm going to look at just this group by itself, saying what's my GCF and what's left. And then I'm going to look at this group here and say what's the GCF and what's left. Okay, so let's see. What's my GCF? It's A. What do I have left? B plus 7, right? So once I took out the A's, I have the B plus 7 left. Okay, over here, what's my GCF? So remember that 14 can break down to 2 times, actually, you know what? Let me erase that. This can break down to 2 times 7. So what do I have in common? I have the 2's in common, and that's it. So my GCF is a 2. And then what's left? b plus 7. And I want you to notice that the two parentheses looks the same. And it's always going to look the same, just so you guys know, okay? So now the third step is going to be factor as a whole. Okay, so factor as a whole means I gotta look at this whole thing. Okay, don't forget the plus here. I gotta look at this whole thing and say, okay, what's in common? Well, the b plus 7 is in common. Awesome. So what do I have left? I got the a plus 2 left. And that would be my answer. Okay? So that's it. That's how you factor using factor by grouping. This is how you factor 4 terms. Oh, you want another example? Sure. Now this example here is going to help you out with another thing that you might see. Let's do this. 18xy minus 4x minus 9y plus 2. Okay? So step 1 is in red. I know it's very difficult. Ready? Whoa. Okay, step 1 is done. Step 2, factor each group separately. So first group, what's my GCF? So if I looked at this group, I can say that this is 2 times 3 times 3, and 9 is 3 times 3, and 4 is 2 times 2, okay? Let me see here if I can write this a little differently so it looks a little better. So 2 times 3 times 3, 2 times 2, 3 times 3, and this is just a 2, okay? All right, so if I just look at just this piece right here, what's in common? I have a2, but that's it. And then they both have an x, so I can take out an x, but the second term doesn't have a y, so I can't pull out a y. So my GCF here would be 2x, and that's it. So let me highlight it. The 2 and the x, the 2 and the x, right? Because the other term doesn't, the second term doesn't have a y, so I can't pull it out. All right, so what do I have left? I have 3 times 3, which is 9. I have a y, and I have a minus, and I have a 2 left. Okay? Now, here is an asterisk. Okay? So, here's the asterisk. If third term is a negative, which it is, pull out a negative. In other words, my GCF wants to be a negative, all right? So I already know I'm gonna pull out a negative, but let's look at what's in common first, okay? So, can I pull a 3? No. Can I pull a 2? No. Can I pull a what? No. Dang it. I have no other GCFs, but I do know I'm gonna pull out a negative 1. If I pull a negative 1, the negative 9y would become a positive 9y, and the positive 2 is going to become a negative 2. Okay? Because, number 1, I want these two to look the same. But the reason why it will flip the signs is because if I was to distribute this negative 1 back in, will I get this back again? And the answer is yes. Only if I had positive 9y minus 2, okay? So third step is to factor as a whole. So I'm going to factor as a whole. What's in common? So 9y minus 2 is in common. And what is left? The 2x minus 1. So that is my answer right there. Okay? And let me put this asterisk in a box as well. Maybe that will kind of give it some attention. Okay? So hopefully that helps. If you have any questions, let me know.